Hello everyone, TSM here, and well, here's you versus the person she tells you not to worry about. So one of the things I like to do now that I've got a 3D printer and when I'm bored is to make stupidly bright devices. This one being one of them. This is a 120 watt LED torch. It's got a big fat lithium battery on it just so that I can actually freaking run the thing and make it useful. And it's got a pretty decent ka-chunk switch on it. In terms of overall controls, we have the main 100 watt LED here, and then two smaller 10 watt LEDs, which makes up that 120 watts. We have two cooling fans in this thing, as well as two heat sinks. So we got the main heat sink, which is a CPU cooler from an AMD FX 8150. Just about enough to cool this thing locally. And on the back we have a heatsink for the power module and of course an exit for the hot air. For a top view, if I just tilt this downwards, we can see here we have our two 10 watt segments here, so I can switch these on and off independent of the main LED. We have the main LED here, and then we have a brightness adjustment for that LED. So if I just switch this on again, you can hear that the fans spin up. They both spin up to a low speed initially, so just sort of supplemental airflow through everything just to make sure the voltage converters don't get too toasty in there. It's not deadly necessary, but it's the way that the fan controls behaved. So if I flick this on, there's the low mode, and I can turn this, and as you can see it gets progressively brighter. So pretty nice, makes it nice and versatile. And then of course we've got the two 10 watt LED units at the front there, so you can see again if I just switch that on, there's 10 watts, there's 20 watts, probably somewhere around a 30 watt, and then if I crank that sucker up so that it overexposes the ever-loving hell out of the camera, that's 120 watts. And because it's DC, I can just crank down the exposure, and I'll just see if I can get you a view of the diodes on this thing. I'm not sure if I will be able to, but we're about to find out. Nope, still a little overexposed, so I would have to get my ND filter out for that, which I don't wanna. Well, there you go, you can see the diodes when it's switching off. So yeah, that's the 120 watt version. Now, obviously, I like to take things a little bit more to an extreme, so this isn't the only one I built, because I made this absolute freaking behemoth. And taking a look at it, this is the back view here. So what this is what I like to call my 1000 watt quote-unquote porter flood. And in all honesty, I probably didn't need to build 1000 watts worth of freaking LEDs into one, like, freaking lantern. But I did anyway, because, you know, why not? So how this came about is these great big massive lithium cells that I have down here. So each one of these, and there are 5 in this torch, is a single 20 amp hour lithium ion cell, pouch type cell. Same kind of deal that you'd see in, I don't know, a freaking Nissan Leaf or something like that. And I got 5 of them. Each one of these cells can do 60 amps continuous. So I did a calculation. What would it take to do 5 cells in series at 60 amps? And it came up to just about 1000 watts. That's when the light bulb moment hit, and I thought, you know what? I could probably put these into a torch. Hey presto, a couple months later, got the bits together, made this monster, and 3D printed a housing for it. So, in terms of cooling then, since we already know it's 5 times, well, put my teeth in, it's 10 100 watt LEDs. Each sort of set of LEDs is switched as a 200 watt pair. So you can only switch this thing on and off in 200 watt increments. So since you now know that, you can probably tell why the cooling setup that this thing has is kind of necessary. And believe it or not, it's just about enough to cool this thing. So what we have, to attach the LEDs to the actual sort of cooling system, we have a big thick aluminium plate here, which is then attached to some aluminium water blocks. There are 5 40mm by 80mm water blocks back there that are held in place with thermal glue and thermal paste to aid in heat transfer. You might see this big fat negative wire here. That is 10, actually no, it's 12 gauge, sorry. that we're using for that so that we can actually handle the current. Don't really know exactly how much current we're using here, since these things are being switched at like 70 volts or something like that. So it's probably fairly low, even though it's 200 watts. But yeah, outside of that, it's fully liquid cooled. There are two 120 by 2 radiators, so in the computer world you'd call them 240mm, because that's basically the length of it, and then your height's 120mm because of the fans. So we've got 2 radiators either side, and there are some rather beefy fans in here, so if I just, I don't know, thumb for scale, it basically takes up roughly, yeah, I'd say these things are probably a good, say, inch or so wide there. In fact, if I just take my little 120 watt jobby for a sec, I'm just going to fire it up. I'll see if I can get you a view in. You might already see the contacts that are in the battery pack just down there. Oh, there we go. That's a little bit better of a view. So you can probably just about see the fans there. And then inside, with a little bit of overexposure, apologies, you can see the secondary water pump. So this thing has dual redundant water pumps in case one fails, because if you have a pump out on this thing, it will get that aluminium plate at the front very toasty very quickly, and you really don't want that with LEDs, considering they just do not like heat. So that's that. That's your sort of cooling setup. At the top, we have the reservoir water pump combination there. This feeds out from here into the LED array, through the LED array, through one of the radiators, back around into this radiator, through that pump, back through this one, and it sort of, the cycle continues. And then outside of that, we have the controls at the top. So what we have here is just 5 fairly chunky power switches. Again, this thing's switching at like 70 volts, so we do need some fairly decent ka-chunk style switches. And we have the master breaker back here. Again, it's quite beefy. That's by design. It has to be, because if it wasn't, it wouldn't be able to handle the ridiculous currents that this light puts out. Well, requires. Again, at the full power draw that this thing's doing, it's over 60 amps in terms of current. So these wires are just about enough to handle that, including the connections inside the actual unit as well. I'm not sure if I can get you a very good view. You might just about see the lights on the boost converters that are being used in there. Again, there are 5 boost converters. Each one is already preset with the sort of power and current limits required to run this thing. And additionally, you might not hear much noise at the minute. Probably a slight bit of pump whine, which is fairly normal when this thing's idling. And that's because the fans are temperature dependent. So if I start switching this thing in, so that's 200 watts, 400, 600, 800, and there's your 1000. God, that's bright. Then it'll start generating the heat necessary to kick these fans on. And then it sounds more like a car when it's been sat idling for like 25-30 minutes. So I can actually also use some of that light now, just to give you a bit more of an inside view. So the way that things are mounted, so you've got your radiators, both left and right. You have your fans mounted to the radiators, and then attaching the fans together is these plastic plates in here. So there are 4 plastic plates in total, and they basically give this light the rigidity it needs to actually be able to handle being picked up, carried around, you know, the usual stuff that you would expect from a torch of this caliber. And then we have our 4 great big beefy 120mm fans, which just decided to kick on. Now, you might notice that these fans are blowing inwards into the cavity inside the torch. That's somewhat by design, because you might notice in the roof of one of the sorry about that. So if you notice in the roof up there, you might see a hole. That hole is to be able to provide supplementary airflow up through the boost converters, because they do get kind of toasty up there. So I can actually feel some airflow coming up through that cavity and out of the boost converters, and it is quite warm air. So is the air that's coming out of the actual sort of back section there, but it's not insanely hot. It also does push some air through the front of the light as well, just to help sort of get some airflow over that aluminium plate. And then of course that still provides sufficient cooling for all of these LEDs, that front plate only really gets up to maybe 45 degrees Celsius under full tilt, like it currently is. And it just stays there the whole time. It's actually quite impressive how well this cooling system works, considering it is literally just 2 aluminium radiators from a computer. But yeah, so that's my 2 fairly high-powered LED torches. I hope you enjoyed this video. If you did, leave a like, comment. If you feel so inclined, you can even subscribe if you like. And I will see you guys when I start messing around with more high-intensity discharge stuff, because I've got a couple of 400 watters that I kind of want to fire up again. So I may well do that with the ballast you see behind these 2 torches. Anyway, I'm out of here. I'll see you later.